Hey everybody, it's Miss Phoebus and I'm back with Lesson 19, Characteristics of Graphs and Functions. There's quite a bit of vocabulary and examples in this one that you might want to go over to the slideshow and set up your notes before you actually watch the video. That might be a little bit helpful. All right, so on a sheet of notebook paper, we're looking at words you know and words you don't know. So the words are in behavior, x-intercept, and y-intercept. All right, in behavior, what's going on at the ends of each graph, where the graph is headed, and we're going to introduce this notation to you a little bit. You read the top line as x approaches negative infinity, y will approach something, some value. And then as x approaches positive infinity, y will approach a different value, or maybe the same value. It depends. The x-intercept is a place where the graph crosses the x-axis. A function can have more than one x-intercept. And the place where a graph crosses the y-axis is called the y-intercept. A function can have only one y-intercept. All right, I can define and recognize the key features in graphs of basic functions. So we're only going to look at the red ones. We're going to look at intercepts, both x and y. Intervals where the function is increasing, decreasing, and then I like to throw a constant in there even though it's not talked about right now. We're going to look at symmetries and end behavior. So we're dealing with 4 different things. Okay, so x-intercepts. A function has an x-intercept if it crosses or intersects the x-axis. An x-intercept occurs when y equals 0. So if you were going to plot x-intercepts, the y value, the y coordinate would always be 0. And then a y-intercept, a function has a y-intercept if it intersects or crosses the y-axis, and y-intercepts occur when x equals 0. So on the y-axis, all of the x values are 0. All right, so we have a graph here of, do you know what kind of function this is? Try not to look at your notes. This is an absolute value function. All right, we're looking at x-intercepts. So x-intercepts are places where it crosses the x-axis. So we have an x-intercept here at -3 and an x-intercept here at 3. Now you can write -3 and 3, but what you're going to see me write is that it's occurring at, and these are the order pairs, -3, 0 and 3, 0. I'm okay with either of them, but I really like writing them as ordered pairs so that you can see that they are x-intercepts by looking at their coordinate and seeing that the y values are 0. All right, let's look at the y-intercept. The y-intercept here crosses the y-axis at -3. So you could write -3, or if you write it as an ordered pair like you're going to see me do, you're going to see that that is different from our x-intercept. Even though they're both -3s, they are different from each other in their coordinates. All right, let's look at domain and range one more time. Let's look at if we've got it or not. So how far left can this function go? So I'm going left, I'm going left, I'm going left, I'm going left. So it's going to go left to -infinity. How far right can this function go? Going right, 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 forever to positive infinity. Infinities get parentheses. All right, now for range, how low can this function go? Looks like this right here is the lowest it goes. It goes to -3. So because I can point at it, touch it, graph it, it gets a bracket. Comma, what's the highest value? Well, it looks like both ends are headed up, right? That end's headed up. When does it stop? Never. It stops at infinity, and infinity gets a parenthesis. All right, you need to know how and where to look for an x-intercept, how and where to look for a y-intercept, be able to state what those are, and know that I'm going to write them as order pairs because that's my preferred value or way to write it. You are going to need to also make sure before Friday's test that you are ready for domain and range. So here's another X-intercept, Y-intercept. So why don't you pause the video and try problem number 2. X-intercepts, where it crosses the x-axis, so right here is an x-intercept, right here is an x-intercept, so it's crossing at -3 and +5. Notice I'm writing minus points. All right, where does the y-intercept occur? Some people might say 1, 2, 3, but I disagree. There's a number there, and it's at 0, 90. All right, how far left does this function go? Looks like it's going to keep on going left forever to -infinity. How far right does this function go? Looks like it's going to keep going right forever to +infinity. All right, how far up? Well, I'm still going to think that it's going up forever to, I got to do down first. Down first, Miss Phoebus. -infinity. Now we can go up to +infinity. So domain and range. And this is actually part of one of our function families. It's been kind of stretched and pulled and funky, but this is part of our cubic function family. Do you see it? It's been stretched and pulled and twisted a little bit, and we're going to talk about that in our video tomorrow. All right, so how'd you do? X-intercepts, Y-intercepts, domain, range? All right, graphs have line symmetry. Now you can have multiple different versions of line symmetry. We are interested in vertical line symmetry. And so we will look at either the y-axis or another vertical line slicing our graph into 2 pieces that match. So my red piece is like a mirror image piece to my right blue piece. Okay, and so because of that, it has line symmetry. So, which of these have line symmetry? Pause the video, see if you can figure out if there's any line symmetry. All right, number 3 has line symmetry because I can drop a vertical line and the right side and the left side match. So it has line symmetry. All right, 4 also has line symmetry. It's not along the y-axis, it's along, along x equals 7, but the left side matches the right side. And this is our quadratic family. So quadratics have line symmetry, absolute values have line symmetry, and then here we have just a linear function. There's nothing splitting it in half, so this is no line symmetry. Okay, so the question is, can you cut it in half, fold it over on itself, make it match, make it line up? All right, we always read the graph from left to right. So if the graph is going up, it's increasing. So if you see here in this picture, I have an increasing because it's going up as I go from left to right. There's another increasing part here. And then if the graph is going down as I read it from left to right, is decreasing. And if it stays flat, it's constant. Okay, so I have increasing, constant, increasing, decreasing. Now we're going to talk about specific intervals. You are not going to have any of this in your homework, but that doesn't mean that you don't need to know increasing, decreasing, constant, all of that. It's just right now, usually I do a color coding thing, and right now it's hard to do that. So I kind of, unfortunately, I was bad. I ignored it. But it is important for you to learn, is the function increasing? Is the function decreasing? Is it constant? Where is that happening? So I'm going to walk you through how to state these intervals of where they're increasing and decreasing. So I'm going to do a little bit of color coding myself. All right, so what we're going to do is I'm going to show you in this example, highlight the increasing part, blue or green, highlight the decreasing part, orange or pink, and then highlight the constant part, yellow or purple. I don't have a yellow or a purple, so I'm going to go with green for increasing, orange for decreasing, and then I'm going to do a blue kind of-ish purple for my constant. And then we're going to list the intervals. So it doesn't really matter where you start, but I really highly recommend starting on the left. And so what I notice is that I am decreasing in this first part. So I'm coming from negative infinity and I'm decreasing. I'm going down, 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 down till right about here. Then I stop and I turn around and I go up. So I am decreasing from negative infinity gets a parenthesis, all the way to negative 3, and negative 3 gets a bracket. Then I'm going to switch to increasing. So I'm going to switch colors, and I'm going to increase, 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 and it always goes from left to right, just like you read. So I'm going up, and sometimes people will actually write, kind of like in that other picture, increasing, or maybe they'll write D for decrease or something like that. But we're increasing from negative 3 right here all the way up to about, what do you think, about 2.5? So we're increasing from negative 3 to 2.5. And then it's like a roller coaster. It went down, now it's going up, now it's going to go back down. And it's going to pick up here and go down, and it's going to keep going down forever, all the way out to negative infinity. So we are going to start decreasing at 2.5, and we're going to increase until we get to infinity. So that means that there is no constant area, none. All right, let's look at number 7. Like I said, I like to start from the left and go to the right because that's how you read your graph. So the first part of my function is this piece, and this piece is different than, I didn't have one of these in 6. This is different, this is constant. So I'm constant between, this looks like it says 1.0. And so that would be 2, 3, 4, 5, 6, 7, 8, 9. Okay, so I'm constant between 0 and 1, and these are all about x values. So between 0 and 1, I'm constant, and then I pick up a decrease. So decrease is orange. So I'm decreasing here from 1 to an x value of 2. So from 1 to 2. And then I'm increasing, and I'm increasing starting at 2. I'm going up, 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 up. I'm still increasing even though my rate of increase has changed. I'm still increasing all the way through. So I started at 2, I went through 3 and 4, and I'm stopping at 5. So from 2 to 5, I am increasing. All right, then I pick up another constant piece. So that is from 5 to 6, I'm constant. And then I decrease, and then I have another constant piece. So decrease from 6 to 7. And then I'm constant from 7 to 8. Except my line doesn't look constant. Constant from 7 to 8. And there we go. So you are identifying as you go from left to right, where is that starting point of it being constant or increasing or decreasing? Where is the stopping point? And so those are your endpoints, just like we did with interval notation. We have a starting point, we have a stopping point. If we can put our finger on it, it gets a bracket. If it has an open circle or it goes off to infinity, it gets a parenthesis. All right, I like to fit this in here because it's pretty easy. A graph that is not a straight line is a nonlinear function. A graph that is a straight line is a linear function. So all of these green lines, they're linear. All of these orange lines, I guess they're orange, maybe red, they are nonlinear. So the question is it a linear function or not linear, not just based off the function, but also based off the equation. So here's 7, 8, and 9. I want you to just write on your paper, sorry, not 7, 8, 9. All right, here is 8, 9, and 10. I want you can sketch the graph, you can write the equation. on each of these, but I want you to write down, do you think that it's linear or nonlinear? Pause the video. Now, I want you to do the same for 11, 12, 13, 14, 15. Pause the video. Now I want you to do it for 16, 17, and 18. Pause the video. All right, you should have done 8 through 18, had some guesses at the very least. It's either linear or nonlinear, it can't be anything else. And all right, so number 8 should be linear. It is a nice straight line. Number 9 is nonlinear. It is nonlinear because it's an absolute value function. Absolute value functions make V's. That is not one single straight line. Number 10 is nonlinear. This is an exponential function. Exponential functions are not linear. That is not a straight line. All right, number 11 is linear. Y equals mx plus b. Remember that? All right, number 12, not linear. It's an absolute value function. Number 13 is linear. It is a constant function going through a y value of 17. It is linear. Number 14, not linear. It is a cubic function. And number 15 is not linear. It is a quadratic function. It is a U-shaped function, not a straight line. How are you doing? All right, number 16, nonlinear. It is a square root function. Number 17 is linear. And number 18 is not linear. It is an exponential function. How'd you do? So can you tell if things are linear or nonlinear based off of their equations and their graphs? All right, and behavior is a description of how the values of a function change as x approaches infinity or negative infinity. So we're going to send our functions to the left and to the right, and we're worried about where the end is headed. So we have 3 different pieces here, and we're going to practice writing. And I want you to go ahead and do like a little quick sketch, and then for each one, we're going to send x to, I like to do negative infinity first. Y will approach something, and then x approaches positive infinity, y will approach something. So we're going to do that for each one. As x approaches negative infinity, y approaches something. As x approaches positive infinity, y approaches something. Hey guys, I've got a special surprise for you. If you can email me your middle name, I will get you a special surprise for the test. As x approaches negative infinity, y is doing something. As x approaches positive infinity, y is doing something. As x approaches negative infinity, y is doing something. As x approaches positive infinity, y is doing something. All right, so basically with your x approaching negative infinity and then positive infinity is telling you to look left. The negative infinity says look left. Tell me what the y value is. The positive infinity says look right. Tell me what the y value is. So for the negative infinity, I'm going to go look on the left-hand side. And my graph is headed up to what y value? All the way up of positive infinity y value. All right, with x approaching positive infinity, that says look at the right. So I'm going to look at the right side. What y value am I approaching? I'm approaching a y value of positive infinity. So this is in behavior. What are the ends doing? All right, let's look. Left is negative infinity. So I'm going to go on the left side. Negative infinity says, where am I going in the y direction? I'm going down to negative infinity in the y direction. All right, as x approaches positive infinity, I'm looking on the right side. Looks like my y values are going to go down, down forever to negative infinity. So the setup is always the same. The question is, as x is heading in that direction, what is y doing? So you're always filling in these blanks for y. So as x approaches negative infinity, that's the left. Looks like I'm headed up to positive infinity. As x approaches positive infinity, that's on the right. Looks like I'm headed down to negative infinity. All right, on the left, as x approaches negative infinity, it looks like I'm headed down to negative infinity. On the right, as x approaches positive infinity, the y value is headed up to positive infinity. So it's what's going on. If you notice, on every single one of those, I circled the ends of the function. It's end behavior. What are the ends doing in the function? So if you are asked about end behavior, look at the ends. Where are the ends headed? I don't care what's going on in the middle. You can be doing all kinds of squiggly, weird stuff. That's not important. What's going on at the ends is end behavior. All right, so we're going to analyze a couple graphs and then we'll be done. So, is this a function or not a function? Well, looks like if I drop my vertical line, this is not that great of a graph, but looks like it's going to pass the vertical line test. So this is a function. It passes the vertical line test. Is it discrete or continuous? Well, it's made up of dots, so it is definitely discrete. Is it linear or nonlinear? Technically speaking, if I drew a line through these points, it would be a straight line. So we're going to say it's linear. The line's not really there, though. Does it have line symmetry? No. Lines, linear functions, do not have line symmetry. Domain, and this is the reason why I want to talk about this versus our continuous functions. The domain, you have to list each and every x value for range, each and every y value. No repeats. You guys keep repeating things, and I'm going to mark it wrong. So it looks like we have x value of 1, 2, and 5. And then we go back and do our y values of 1, 2, and 5. Does it cross the x-intercept or the x-axis? No, there are no x-intercepts. Does it cross the y-axis? No, there are no y-intercepts. So you can analyze a graph like this. Pay attention, know the difference between the domain and range of a discrete graph and the domain and range of a continuous graph. All right, here's a different graph. Is it a function or not a function? It passes the vertical line test. It's a function. It's actually one of our function families. Do you know what function family it belongs to? It is the quadratic. You need to know that based on its shape. So know what a quadratic function looks like. Is it discrete or continuous? Well, discrete made up of dots. Continuous is made with a smooth curve. This is a continuous function. Is it linear or nonlinear? Linear is a straight line. This is not a straight line. It is nonlinear. Does it have a line of symmetry? Yes, it does. It's actually right through here. X equals -2. That's its line of symmetry. Yes, it does have line symmetry. And this is very similar to what you're going to be doing in the homework. Okay? The domain of a quadratic is from -infinity to +infinity. Now the range is a little bit different. We want to go to the lowest point. Looks like right here, -3 is my lowest point, so it gets a bracket. The highest point is infinity. Does it cross the x-axis? It does. It crosses twice. We're going to have to estimate those. So I don't know, about 1.5. That's the one on the right. Not 1.5. All right, so about, it's not quite a half, maybe like 0.4. You're allowed to estimate these. And then for -4 point, I don't know, -4.4. It's not quite halfway. It's close though. If we called it halfway, it would probably be okay. All right, the y-intercept, where does it cross the y-axis? It only crosses one time right here. So we're going to have at 0, -1. And then in behavior, as x approaches negative infinity. That means as I go left forever, what's my y value doing? It's going up to positive infinity as x approaches positive infinity. So that means right. As I go right forever, what's my y value doing? It goes up to positive infinity. All right, let's look at one more. I would like to see if you could do it. So pause the video, look at graph 2, see what you can do on your own, and then unpause the video, and I'll walk you through it. All right, so let's look. Is this a function? Yes, it is. It is not one of our function families, though. This is a x to the 4th function family, which you don't have to worry about. It is continuous because it's not made up of single spaced out points. It is made up of a curved, smooth line. It is nonlinear because it is not a straight line. It does not have a line of symmetry because if I tried to cut it even right here, the left side doesn't match the right side. So it does not have any line symmetry. Domain from negative infinity to positive infinity. Range looks like the lowest it goes is about -4 to positive infinity. It's got several x-intercepts. It's got 1, 2, 3. So we've got to list them all. -3, 0, 2, 0, and 5, 0. And then the y-intercepts, or is across the y-axis, looks like right here at -2. So 0, -2. All right, now we're ready for end behavior. Look on the left side because that's what goes to negative infinity. My y values are headed up to positive infinity. Look at the right side. That's where x goes to positive infinity. My y values are headed up to positive infinity. All right, that's the end of the video. Make sure you've taken good notes. There is an open Google Meet today, so if you need to meet with me about anything, please let me know. I'll see you in the next video. Make sure you're getting ready for the test.